Has struck 11, so we can officially start. Happy Friday, everyone, and welcome to part two of the civil collaboration series, where we're going to be looking at using Civil 3D, Revit, Infraworks, and Inventor, which is a bit of a wild card to the AEC collection. So yeah, if that sounds good, let's jump in and have a look at what we're going to be doing today. So if you are the first time joining the series, of course, it just kicked off. If you missed part one, it is uploaded to our Baker Baynes YouTube channel, so you can always go and catch up there. But a little bit about this series and the background about it. Of course, I am your host, Shuaib Yunus. I'm the BIM technical specialist specializing in civil infrastructure and mining here at Baker Baynes. I'm also a civil design technologist, and I've been part of the civil engineering community for quite some time. This is a 5-part webinar series, and it's going to be looking at collaboration across various software/disciplines in the infrastructure industry. So I sat here and dealing with a lot of designers throughout the world. I picked up that there's a lot of problems when it comes to collaboration. How do you make different software talk to each other and give you the output or accuracy that you need? And this led to the concoction of this actual civil collaboration webinar series. Of course, it's going to be focused primarily on civil collaboration, so purely collaboration. However, there is some modeling aspects that I am going to be showing you. Like today, I'm going to show you how to actually model something in Inventor. Okay, so today, of course, we are in the mix of software with Civil 3D, Revit, Infraworks, and Inventor. And of course, the software that I plan to use throughout the entire series is that whole stack that you're seeing there. It's quite a bit. It might increase depending on what comes in to my mind as the time goes. But now that you have some background, let's look at the actual agenda for today's session. So of course, we always have great attendance, which I'm very grateful for. So we always have a quick introduction on who Baker Baynes are. And then we jump straight into the topic at hand, and we're going to be covering those type of subsections there: modeling in Infraworks, bringing your civil design to Civil 3D, modeling a bridge, placing a building coordinated as per a civil coordinate, very important. And then, of course, looking at how it links to Civil 3D, Revit, and Infraworks. So let's jump into Baker Baynes. Of course, we stand by the slogan or the motto that we solve our customers' problems through digital transformation, helping them to design and make a better world. So if you wanted to know us in a snapshot, this is the perfect or the most condensed form that we can actually bring to you. We specialize in those 4 main segments. We have a lot of technology partners that we partner with or integrate with. And of course, we are part of a very niche market where we are an Autodesk service provider select, meaning that we have the expertise, the consulting methodology, the know-how, and the correct personnel to actually help you to design and make a better world, and also to do your consulting design projects. And we're also listed as on the Autodesk Services Marketplace as a provider. So you can always find us on there. And yeah, we offer training. We do also selling of the actual software, but we help you implement it so that you can actually use it. In terms of the brands that we support and we back, of course, everyone knows Autodesk. They are the leaders in design technology throughout the world, highly adopted. Your hero products being Civil 3D, Revit, AutoCAD, Inventor, Infraworks, the main ones, but they have a whole list of products that can actually help you to design much more better, or what we would call, they have a BIM enabled or BIM intelligent tools that makes design very, very intelligent. In terms of laser scanning, we partner with Leica and Topcon. Leica for more building scans, interior, architectural space, those type of things. Very compact little scanner, the BLK 360, which you're seeing there. It literally fits in the palm of your hand, very versatile, easy, and very simple to use. And then if you're looking at something more rugged or purely civil infrastructure, we've got Topcon. Topcon has a variety, a widespread of construction technologies that you can use, from machine control, automation, grading. They have a very wide portfolio. In the laser scanning space, we use the GLS 2000. Of course, the picture that you see there is the actual latest model, which is the GTL 1000, very, very versatile. But we predominantly use the GLS 2000 because of the range. It starts off with the entry level being at 120-meter range. The BLK 360 goes to a 60-meter range. And if you want to go to a much more further scanning range, we've got options to go for a 350-meter as well as a 500-meter range. It's just quite a lot. Perfect for road design, construction applications, and so on, as well as mining. IDAS, you should know by now, that was my last webinar series where we applied it for stormwater design in conjunction with Civil 3D. Very, very powerful tool. Civil 3D, I actually use their template, which is brilliant. It comes with a lot of styles, very, very useful. Definitely check out their website. If you just Google Devotech IDAS, the website is there. You can actually just log in, create a free account, and you can also download that template to be used in your designs. So definitely check it out. I strongly recommend IDAS to be used in conjunction with Civil 3D. It's developed for our South African market, but it's also used throughout the entire world. Very, very good functionality. And last but not least, CAD learning. CAD learning is a brilliant tool if you're a designer working on multidisciplinary projects, you using different software, you need to upskill on the go. It's an online portal where it has the majority of the Autodesk software where you could learn pre-recorded videos, exercise files that you could actually use and learn. Just to name some of the software that are on there, Civil 3D is on there, Infraworks is on there, BIM 360 is on there, Inventor, 3ds Max, Revit. There's a whole list of software that you can actually learn at your own pace, at your own convenience. You can also test yourself to see in which regions of the software you might need to upskill. Maybe you're lacking in corridor modeling in Civil 3D. If you do the quick self-skill test, it will actually create a formulated, custom filtered playlist that you could watch those specific videos to actually address that problem. And you could be a much more better, well-rounded designer. I myself use it for my own development, and it works brilliantly. In terms of the segments that we support and specialize in, we've got the build segment, which is vertical construction, where we do architectural buildings, structural designs, anything going towards the sky, if I could put it that way. We specialize in that. We've got the manufacturing space, which has become very closely related to construction, especially with prefab design and building. So we also specialize in that. I play a little bit in all of these fields, but mainly in civil infrastructure and mining. That is my domain. So roads, pipe networks, civils, grading, scanning, mining, modeling, those type of things. And then of course, energy, which is a big part of the electrical space, process plant energy and mining space. So we pretty much got the main segments of industry covered, and we can actually help you to and assist you in your design applications. So please do reach out to us. Our details will be at the end, as well as my own personal details if you want to reach out, and we can have a chat. And last but not least, the last slide on us is we base this on an IADOC methodology where we don't just sell you software, but we help you implement it, adopt it, and wield it to your benefit. So we assess your current situation, we educate you to fish for yourself where we can, and if it's a little bit above your depth, we can consult and work with you to get on a project. This helps us to bring in digital transformation in all of those industries that you've seen previously, and we facilitate positive change management in design, making it much more digitized. Okay, great. So now that you have our credentials, a very quick few slides, I think it was 4. Now let's jump into the exciting technical part of it. So the Civil Collaboration Series Part 2. So I always create a scenario, so it creates more context to what we're doing rather than just jumping into the software and giving you some random know-how or where to click. I focus more on understanding. If you understand it, that is perfect to me. Okay, so I created a scenario where we had identified a land or a plot or an earth where an office park will need to be developed or designed. The site is based in Hartiesdam, South Africa. Okay, so I did create something that's local to us. And then, of course, the office park will be consisting of a variety of civil infrastructure elements. As you saw in our previous webinar, we did roads, roundabouts, intersections, as well as gradings, but there's much more that's going to be added to it, namely buildings, landscape architecture, decorations, those type of things. And what we're going to be doing in the series is we are going to produce this or develop or create this office park from the conceptual stage right up to final visual design. Okay, so we're going to be building on the same model, which makes it quite nice. So at the end, you're going to be really, really mind blown to see what you can actually see as well as visualize to portray design intent. So let's kick off with our step-by-step. So first of all, we're going to bring in the civil design that we've done in Infraworks to Civil 3D for detail design. So how does this look? So this was our Infraworks model that we stopped at the part 1 of the actual webinar series. So let's have a look. So here we are. You can see there's a ton of intersections there, quite a bit. There's a nice big roundabout. There's some coverage areas, and of course there's a grading. We've got this road here, which I have titled Bridge. Okay, as you can see there, I gave it a name. And we're going to get to the bridge design part a little bit later in the webinar. So structural engineers, I think you're going to really enjoy that. Now I'm going to bring this into Civil 3D. I'm using the Devotech IDAS template for Civil 3D. Again, I'm a strong advocate. It's a brilliant template for us. And before we get into it, I'm going to go and set the coordinate system. So this was part of the Hartbeespoort LO27 system in South Africa. Of course, we applied a coordinate correction in the previous webinar, quite easy, straightforward. If you want to go and check that out, please go to the YouTube channel and maybe play it a bit slower so you can pick up on the steps, but it's quite straightforward. Now you can see it is geolocated. The blue tab on the top has popped up. And now we're going to go and import our Infraworks model. So it's an SQLite file that normally saves all the data. And once you import it, it should confirm that your coordinate system matches, or you can actually target a different one depending on what you need. We're going to be using the same one because it has been created. Now, if we go to the refined selection set, this is where we can actually edit what we want to import. Okay, it might take a few seconds to load depending on your computer as well as the amount of elements in there. I do not want the planning roads, so I'm going to uncheck them. And I want the component roads, the intersection. I'm going to uncheck the bridge because it's not done yet. And yeah, I think I can bring in the rest of the data. So we're just going to hit OK, and then we can hit Open Model. Now it will start importing the entities. Sometimes it can take a minute or so, depending on the extent of your model, as well as the entities that are actually present in it. But mine has never been longer than a minute, to be quite honest. So we'll just give it a few seconds so it can actually load. And then you should see on the bottom right corner, it will start importing all the corridor, the modeling data once the import is finished. So once it is finished, just give it a few more seconds so that it can actually process that data, which is quite a bit, right? So as you can see, my cursor is flashing a little bit because we are bringing in that data, and we will just give it a few more seconds. And yeah, I think that's it. And we can actually go and zoom into our site. So let's go in and see how the data translation comes in from Infraworks. So as you can see, the surfaces come in. They are currently set to border only. But if we go to our prospector, those are all the data that has brought in from Infraworks. Very, very cool. I mean, it's much more quicker. You've got offset alignments that you would need to target to. For the intersections, you can see the bridge. I did not bring in that data because I'm going to detail the bridge later. And yeah, you've got a lot of stuff happening in here. You've got the surfaces for different objects. If we zoom into the roundabout, you can see that that corridor comes in. But if you look at the intersections, they're not really done. The offset alignments are there, so you would still need to do some tidying up in terms of the targeting and stuff like that. But that's quite easy. I mean, it's much more easier to start from something rather from scratch. And just to confirm that the geolocation is correct and our model is coordinated, I'm going to switch on the geomap. And as you can see, it sits in perfectly where I want it to be. Okay, I'm just going to crop this model, so I don't want the entire map because it will affect your performance as you zoom in and zoom out. So I will just capture that area and I will switch or crop that map aerial to off, and here we are. I have now the background image, right? I can also go and toggle the clarity of it, make it more fine. I like things fine, right? So it's much more sharper and clearer. So here we are, this is how it comes in. And you will just have to go and tidy up the corridors, create your final combined surface, those normal Civil 3D steps. I will give you a peek of it in part 3. I will just leave you a little bit hanging for that to see how it looks. But yeah, that's how the data comes in. Pretty damn cool. Okay, now the fun part starts. Now we have a building that we want to correctly position, not only in Civil 3D, but also in Revit. What we pick up is generally the architects will do their design and they will model using the internal coordinate system in Revit, and that is not coordinated. Okay, we need to coordinate it to the civil model because the civil model dictates or governs the positioning. All right, so anything that you're exporting positioning wise, don't do it in Revit, do it in Civil 3D. It is catered for that. So let's have a look at what I'm actually talking about. So again, I'm painting another picture for you guys so you can actually understand what I'm doing. On your right hand side, we've got the building. So that is the architectural building model in Revit. And the picture below that is the position, the XY position that it needs to be placed on site. So that is the building footprint that you see. And relative to the site, it needs to be positioned at those coordinates. So that yellow X that you're seeing, that is the point that is going to be used as a reference. Okay. So the design is done. It's come to a final level. You know where you need to position it per the civil engineer or the surveyor in terms of the positioning. And now we will need to coordinate it so that it is positioned correctly in Revit as well as in Civil 3D. So let's have a look. So here we are. This is Civil 3D. You can see we've got our COGO point there. If I go to the point group properties, again, this is the IDAS template. It applies the label correction where you swap the X and Y in the internal system and you multiply it by -1. And then of course, you've got the Z or the elevation that's in there. Now, what I'm gonna do is I'm gonna just isolate the surface and the building so that we can see it much more clearer. So welcome AutoCAD. AutoCAD functions are very critical here as well. And Civil 3D is built on AutoCAD engine. So here we are. And since I've got the 3D model, I've imposed it or imported it into the model. And if I just toggle my view, you can see it is actually in 3D. Okay, there's the position, there's the surface, and there's the building. Of course, you don't need the actual building, but rather the building footprint, even if it's in 2D, so that you can actually give an accurate level. So if we go to our toolbox, you'll see that there's an option called shared reference point, and we will select the one that's called export shared reference points for Autodesk, Revit, and we will select our origin point as well as our quasi Y. So that just gives you the rotation angle of the building. You can see there it has the Z value, it has the rotation as well, and of course the units that you're using. So we're going to use meters. I'm just going to delete that previous file that I've created. So let's just delete it quickly. And once I hit save, or once I save that XML file, I can now go to Revit and coordinate that model. So I will just go back to the top view here just to give you an idea. You can see the surface is there. We've got our Y coordinates, our X coordinates, as well as our Z elevation. Okay, so that was quite easy. Okay, so just to summarize what we did in Civil 3D, we set the location so that it's under the correct allo system or correct coordinate system. Then we went to the toolbox, we went to under subscription extensions, and then we said right-clicked on shared reference point and hit execute. And then we selected our coordinate point, which was given. And then we selected another reference point on that building footprint to allow the rotation of the building. So now I'm going to show you how it looks in Revit. Right? If you have any questions, you're more than welcome to pop them in the chat box. So long, I will address them at the end of the session. So this is the Revit model, right? Pretty cool. And as you can see on your screen, it is not coordinated. If you look at the Civil 3D north, and you can see the angle of the building versus the north here and the angle, it's quite linear, so that is incorrect. And just to prove to you that I haven't coordinated it previously, I will go and create a spot coordinate in Revit just to give you what the current coordinate system is in Revit. You can see already that is way off. That is incorrect. It's using an internal Revit model system, whereas if I switch to Civil 3D, you can see that's the correct coordinate. So I'm going to delete this off here. And the first step that you're going to do is you're going to go to add-ins in Revit, and you'll see that there's a shared coordinate system there. So again, the same manner that we did it in Civil 3D, I'm going to click my reference point. Again, make sure that it's at the bottom of it, right? So that the elevation is correct. I think I just zoomed in a tad bit much. Let's zoom out a little bit. And maybe, here we go. So I will click the bottom of that corner, the bottom of the quasi-Y corner, and now I will go and select the shared reference point that I created. I will hit OK, and once you say yes, you'll see that it says it's successful. But let's go check if it really did the trick. Okay, so it did import successfully, but let's go and check our view cube. You can see it's still not correct because the north is pointing up, of course. And if I switch to Civil 3D, it doesn't reflect the angle of the building. So something's wrong here. Actually, there isn't. All you got to do now is go and set the internal coordinate system to follow what you have exported. So we go to the Manage tab and we go to Project Location. We go to the Site tab and we're going to go select that shared reference point and make it current. And once I hit OK, have a look at the view cube now. Can you see it updated? So I'm just gonna drive a little bit here and toggle this around so that the north faces top. And now you can see the coordination or the angle is correct. It matches what is in Civil 3D right here. The last check we're gonna do is check just to see if the coordinates at that corner matches Civil 3D. So we go to the spot coordinates again. I'm going to drop it at that same reference corner. Right, so let's just toggle it so we can get that bottom corner. So here we are. Let's zoom in a tad bit. Select it, and you can already see the coordinates correct. All right, you've got the 28509 and 79153. So let's go just check it in Civil 3D. 28509, 79153. Perfecto. Okay, so this is how you will coordinate your building. Make sure that it's coordinated in Revit, matches the Kogo point in Civil 3D, and now you know that the architectural model has also been coordinated. It also applies to the structural engineers. Okay. So yeah, I hope that made sense. Okay, now the next step we're gonna jump into is modeling a conceptual bridge design in Revit. I mean, in Infraworks. I get confused because I'm displaying so many software to you guys, but let's have a look how you would do this. All right, so we are back in our Infraworks model. So let's have a look here. I made this quite a video a tad bit longer because I want to actually, so you can see something's wrong there. It looks like a vortex, maybe Thanos was gonna rock up from there through to Earth, right? But we're gonna fix that very quickly. Yeah. So let's go to our Create tab on our Infraworks. And you can see you've got different options here. We're going to go to the bridge. Now it highlights all of the component roads. And what we're going to do is we're going to drop a bridge on this one. So maybe start somewhere there. As you can see, you can type in an exact chainage or station, exact length to be precise. I'm just going to use the click option here for demonstration purposes. And once I specify the extent of my structural bridge, you should see now it has dropped in everything perfectly. How quick was that? If I go below the water, you can actually see the piles and the pile caps. You can see the pier and the pier cap as well. There is actually structural bearings that are in there, and you can actually go and select the style that you want to use. Okay, so again, I'm going to spend a little time on this because I know structural engineers, we normally have a lot of questions. So I'm going to go very slow through this part of things, but it's quite great. These are actually intelligent parametric objects, right? You can see the, I just toggle a little bit below that. We can actually go and click on any object that you'd like. Okay, and you can actually go and customize those dimensions. That is the beauty of parametric modeling. Really, really good intelligent based objects. You'll see if I have to go click on the pile cap, for example, I have all of the dimensions at my disposal to go and actually edit everything. Okay, so I can change the type of configuration that I'm using. This one is a very common one. Of course, you can go and create your custom elements as well, which we're going to get to very, very soon. But you can see how great this looks. I mean, if you can use this for design intent as well as detail design, why the hell not? If something's visual, it makes things easier, not only for the non-technical person, but also for the engineer. I mean, if you're doing a design, you can actually go and show things. You can also get the quantities of the bridge. You can see CIP is cast in place, right? If you're using precast, it'll give you different. There's no rebar quantities because we haven't done that in Revit yet. And of course, we can go and get whatever we'd like from here. We can publish the structure, which we will do just now, or we can send this to a spreadsheet so that we can type in exact values and the bridge will update automatically, which is preferred by many designers. You can also go to the Analyze tab and you can do a line girder analysis. Now, if you haven't heard of this, this is an analysis that's done in the Autodesk Cloud. Pretty damn good. Doesn't need any computing power on your side. It's rendered in the cloud. You can go and specify your project name, your job name, job reference. You can see currently analysis is disabled. That is because I haven't selected a bridge in my model yet. So don't get freaked out if you see that grayed out for all of those type of options. I know the permissible factor is 0.85. Normally, you can correct me if you're a structural engineer there doing bridges. You can up that if you like, depending on what you want. But you see, once I created the bridge, it picked up the data from what I've had created previously. When I last did a bridge demo, you can go and edit those fields. If you run the analysis, you can pick up the result. I have done I think I have done a webinar on this, so it's on the YouTube channel if you want to go check out the report. In terms of the longitudinal sectional or the longitudinal profile, you can see it actually shows you where the bridge is. You can actually go and insert PI, delete them. You can check your cross section. If you have super elevation applied to your roadway, you can actually also go and check that out. Very, very easy to do from this interface. You can see also the changes are given to you, or your ECC, your BCC, if there are any curves, your PI points. I can go and raise this PI. So what I'm gonna do, I can also go and show the station in Canvas. So it will show me exactly where I'm busy with in the canvas. You can see even your X, Y, Z coordinates are correct. If you know South African elevation, that is pretty spot on. But again, survey data governs accuracy. Nothing replaces that. I'm gonna just raise this a bit so that the clearance between the bottom of the bridge to the water is a bit decent. So you can see I have used that, and even the grading for the road has updated dynamically, which is beautiful, right? It's really intelligent, right? So as you can see, that has been done for us. I think that looks a bit better, especially because the bridge is not literally floating on the water. We got some clearance there. I can also go and toggle and adjust certain parametric elements. So for example, if I click on that pier, right? Actually, let me zoom out and show you all of the parametric values that are attached to it. You can see that's what's there. You've got these arrows at the bottom where you can actually rotate it depending on your preference. I can type in a rotation angle, or I can just toggle it like that. So very easy to do that. I can also move or adjust the number of columns or piers, whatever you want to call them. I can spread them out, I can increase them, I can decrease their frequency. And if I reselect that so that the grip turns purple, so let's go click on that pier just one more time. You can see I can just drag to position where I want that pier. So I want it there. I think that's good to go. And I can just click and it will update accordingly. Even the annotation dimensions will update as we go along. So pretty good. Okay, you can see that the columns are a tad bit short. We can always adjust that. This is very, very parametric, and I'm going to show you that in a bit. But you get the gist of it. Everything is very, very customizable and very, very parametric driven. As you can see on your right panel there that I'm showing you, you can go and change things, update things, modify things, and so on. Okay. All right, so just to get more into the structural part of things, you might have a question. How do I see what type of girder profile I'm currently using in the bridge? It's very easy. Let's have a look. So I've created a bookmark to position me below the actual bridge. So let's go and access that. But before we do that, let's toggle the view. There's something called an engineering view where it dims the surrounding features. And as you can see now, we can actually see below the water because it highlights or brings forward the engineering aspects. Now, if I wanted to adjust the length of these columns, I can always go and create the offset of the pile cap and foundation from the NGL. You can see it's set to -20 at the moment. I think let's change it so you can see what I'm talking about. So if I make this -25, all right. So if I type in -25 and I hit enter, you will see that because of the parametric intelligence assigned to it, the pile cap elevation dropped as well as the pier has increased in its length. So that's why I say parametric modeling is amazing. It makes your life so much easier. It's not static. And I can apply this to all of my foundations, or I can just keep it. So let's apply it to all. So just have a look there. And you now would see that everything has adjusted. If you see your columns just a bit disappeared, just maybe pan a little bit. So like you see, I'll just move my model a tad bit and everything updated. So let's go back to the girder. I'm going to make things more pretty again and go to the conceptual view. And let's go to the bridge girders. So this bookmark will take me to the bottom of my bridge. And this is where you can go and preview what girder profile you're using for internal and external design use. There are a lot of them that's already pre-configured in terms of shapes. You can go and edit them if you'd like and save them according to your own dimensions. And as you can see, I can select a lot of different components. This also applies to the bridge bearings that are in the model at the moment. And we can go and even adjust the concrete strength, those type of things. This forms a key role before you're doing the girder analysis, okay? And also, if you're interested on the roadway, you can also go and edit each and every component individually. You can swap them out, you can adjust them, and so on. So yeah, this is exactly why I like Infraworks for bridge design. It's very visual, very easy. What you see is what you get, and it's very understandable. Okay, so structural engineers, I hope you guys are excited there. I'm very intrigued to hear your feedback at the end of the webinar. But let's get into the wild card, which is Inventor. So if you've been using the AEC collection, you do know that Inventor is not in the AEC collection, but how does it link up to our civil infrastructure design? Let's have a look. So I've got a quick slide here. So about Inventor for Infraworks, like I said, it's not included in the AEC collection, but with the convergence of manufacturing and design, I call it Lego construction. A lot of things are prefabricated and assembled on site like Legos, okay? And this is why Inventor is so great for this. Only downside, it's not in the AEC collection. However, if you have a bridge design department or you do a lot of bridges, I would strongly recommend at least getting one subscription of Inventor so that you know that someone can be in charge in the content creation, parametric modeling part of things, and you can save it to your library for future reference. Okay, you can do bridge modeling with Dynamo and Revit, but if you're not used to visual scripting or visual programming, it can be a little bit daunting, right? The learning curve can be a bit steep, but from what I've seen, once you get a hang of it, it makes your life so much easier. It automates a lot of tasks and makes it that much more better. If you have a background in Python, I mean, go for it. I think you'll probably kill it. But maybe next year or sometime soon, I'll try and do something on Dynamo so we can all learn together. In Inventor, its modeling is very easy. A lot of the stuff is more AutoCAD based in terms of the functions like extrude, draw an arc, draw a line, rectangle. Those functions are default, okay? And the advantage of this, it becomes part of your Infraworks library. Now, once it's in Infraworks, and if you got the exact geometry, it makes detailing in Revit so much more quicker because you now know that your geometry is complete. There's not going to be any edits. If there are edits, it will update dynamically, which I'm going to see just now. But it's much more visual. I mean, if you can get the geometry, I would say perfect in Infraworks and then bring it into Revit, when you're placing your rebar and those type of things, you can just start off the bat. You don't have to go and modify any geometry first, make any pier wider, shorter, those type of things. So that's why I say you can start with the detailing immediately once it's in Revit. So what I've done today, disclaimer, I am not an Inventor specialist. It is not my specialization, but I actually found it quite easy to model a part in Inventor and link it into Infraworks. So I have created a modeling video to just show you how easy it is. And let's take a look. All right, so this is Inventor, and I am going to start up a new part. I'm going to make sure it's metric and in millimeters. If you're in the imperial part of the world, you can select imperial, and this is Inventor. Now, the first thing we notice is that the orientation is wrong because if you're looking from the front, it shouldn't be YX, but rather if you're looking from the top, right? So we're going to make the current view to top. Now that is correct. And then we're going to go and select an XY plane. And then we're going to create a pier. So I'm going to type in what I'm actually doing. So pier dia equals to 2 meters or 2000 millimeters, and it's drawn the pier diameter according to what I want. So let's change the orientation. Again, this is like AutoCAD, right? Whatever you're going to see here. I'm going to extrude this. So let's make it 10 meters high, right? Again, with parametric behavior, you can actually edit this in Inventor, in Infraworks to adjust accordingly. So now we've got the pier or the column. Now the next step is to do the pier cap. So again, I've chosen something that's not too easy and also not too difficult, okay? Now what we're gonna do is we're gonna go and draw that. I've selected the rectangle and I'm gonna make the measurement or the distance 3 meters. Now, very important, as you're seeing me typing these dimensions, these have to be exactly written the way you see on your screen, because those are the parameters that will be read in Infraworks. So you see, I've done the right view. We also need to delete that center line because Infraworks is very, very sensitive to overlapping geometry. And we're going to do the same thing on the left. So I will say pier cap left width equals 3 meters. It could be it could also be 4 meters, whatever you want to. It doesn't have to be even or symmetrical. And I have just done that. So again, pretty much AutoCAD. Now what I'm going to do is I'm going to highlight all the vertical lines going onto our screen, and I'm going to change them to construction. Reason being is when I'm going to extrude this later, it will not pick up that circle as well as those lines. So now I'm going to use the arc function, same like in AutoCAD with a tangent, and I'm going to create rounded elements on each end, which is much more realistic. So you see, I didn't just choose a square option, right, guys? I'm showing you something that's quite common in the field. And once we do that, we're going to close the loop, or like in AutoCAD join, if I could call it that. So you would need to click on all of the elements that form that pile, that pier cap. It will tell you that it's joining to a curve. You can say yes. And once you do that, it will tell you that the loop has been successfully closed. And this is what we are left with. Pretty easy, right? Pretty easy so far. All AutoCAD functionalities. You would find on YouTube they do a lot of different objects, but I chose something that's a bit intermediate. Okay. So what we're going to do now is we're going to confirm that the constraints are met. Where is this button again? I'm looking for show constraints. As you can see, I am an amateur in Inventor, so bear with me if I can't find. There we go. It should be that one. So show constraints. And as you can see, as I'm clicking on the object, it shows me where it is constrained to, and that is perfect. If this was green and not purple, that means something is not joined correctly. But in this case, it's pretty good. All right. So what we're going to do now is we're going to use extrude again. So AutoCAD, we're going to invert the direction because we want it to go down from the axis that we started. So we're going to toggle the dimension called flipped. And just to show you, if you select the wrong output, so you've got join, you've got cut. Join is the correct one, but if I select cut, that means it's going to cut from that portion down. So let's select cut and show you what happens. All right, so I'm going to select cut and hit OK. Can you see it removes that as well as cut the column? So I'm going to undo it and we're going to do extrude again. So you can see visually, if you get it wrong, you can always undo. I'm going to select join under the output. And if I hit OK now, that is exactly what I am looking for. So we've got a pier and we've got the pier cap. That's about it. Now the next step is to go and adjust the parameters. Okay, you can see there's an option or a column called key. These are the dimensions that I'm going to export or require in Infraworks. I can go and edit these headings if I made a mistake. So for example, I forgot to put in pier depth, so I'm going to type in pier depth. That is 2 meters. And then also I'm going to make sure that I actually tick it. Let's just check. Yeah, so it's that one more. We can tick that and we can hit OK. I think everything else is quite good. Well, actually the pier height. Yes. So I'm going to go to pier height. You can see I'm going to tick that key, and that is good. So all of the dimensions of the parametric objects or elements have been defined. I then go to the infrastructure export capability, and I'm going to go say export template. Now I can give it a name. So I'm going to call it example peer. So we know that it's this one, and I'm not just using one that's already been created. I'm going to use shaded with edges. I like that one. Hit export, close, and I can save this. All right. So we're done. We've actually modeled that example peer. Okay. You can see it's on the list. And let's go to Infraworks now. So I'm going to click on the first peer, and I'm now going to go and change it. So we're going to go to style palette, and we're going to first add this to our library so that we can use it for future projects if needed. And I'm going to go select the IPT part that I created. I think I had it saved under my webinar folder. So let's just go to that. Let's try that again. Here we go, right? So example peer, it's an IPT format, and you can see it has read those dimensions correctly. If you got a red cross there, you need to go and check your parameters. Again, you've got all of these dimensions that can be edited that come through, or you can add a column with standard part sizes. So you can select different part sizes, but I'm just going to use this one and delete it. And the group name, I'm going to call it dimension. So when you see it on the properties tab, all the parametric functionality will be under the heading called dimensions. This is a nice thing to do. It like filters or creates your properties like in tabs or headings, and all of the dimensions will be under dimensions. You can call it whatever else you'd like, but I'm just using dimensions for you, so it's much more easier to understand. You can see it's a bridge peer, and if I hit OK now, you should see it now in my content or catalog library. Pretty good. Now that it's there, we can go and change that. So here's example peer on our list now. And if I click on it, check what happens to our peer. Pretty good, right? That looks perfect. And even the bridge, the bearings are still there, as you can see above it. And I can either change it for one, but for example, I'm going to apply to all of our peers so that we have continuity in the series. And look at that, really beautiful, right? All of them updated to the spec that we needed to. And if I go, I can always go and modify those parameters as required. So you can see why I really like Inventor for this. I mean, I'm not a pro at it. I've used it and it worked really, really good. So if you have Inventor, or if you want to go and play around with it, download a trial, test it out, and let me know how you came right with it. You can do peers, you can do peer caps, you can do foundations, you can do piles and pile caps, you can do your own custom bearings, you can do your own custom bridge deck, everything in Inventor, and then you can add it to your Infraworks library to be used for future projects as well as modification. So this is why I like the Inventor workflow. But again, if you are a Python fundi, or you got some background, or you're interested in visual scripting, give Revit and Dynamo a shot and let me know how you come on with that. All right, so the last but not least step in our webinar for today is to import the conceptual bridge to Revit and Civil 3D. All right, a lot of people forget about Civil 3D. We need it in our road designs, right, guys? So we want to see it in our long sections, and this is what's amazing with the new workflow. So let's jump into the platform. So we stopped here where we changed all of our peers. I can right click on the bridge, go to publish civil structures and create new. So we're going to create an IMX file. Okay, you can give it a name. I'm just going to call it bridge1 IMX. And it also creates a backup of that conceptual proposal if you have it ticked. If not, no worries. I'm going to go save it to our webinar folder. So September, here we go. We've got the IMX saved there. Hit save. I'm just going to override that one. And you can see backup proposal is ticked. If you have it unticked, it won't back up. So it's up to you. And we hit publish. Now this will create an IMX file, and the great thing with this is if this IMX file is overwritten or updated and it has the exact same name, once you hit refresh on Revit or Civil 3D, it will update instantly in those platforms. So I'm going to switch to Revit, and I'm just going to open a construction template, and I'm going to import this bridge into Revit now for rebar detailing. So I go to the add-ins tab, and you'll see that there is an import civil structures. But first, you've got to save your file. So I'm going to save this very quickly. I will save it in the webinar folder so my desktop doesn't get cluttered. I fall into that trap sometimes, guys. So wrong folder. Let's go to webinars, drop it in September. And yeah, here we go. I will give it a name. SNS, the Civil Collaboration Series, perfecto. All right, so now you will have the option to go and locate that IMX file, which you see on your screen. It's in the same folder. So I will click it, hit open, and now it will load. So again, this might take a few seconds, depending on the extent of your objects. All right, so just hang in there. It's not that long. I think this took about 20 seconds, but that's because I'm also not using a really high-spec computer, right? So there's the check for updates button if that IMX needs to be updated. And this is how the geometry looks in Revit. Now, this is fixed geometry, or if I could call it a block, you cannot edit it. That's why I say do your final geometry design in Infraworks using Inventor. But if I click on object, I can go and actually start with my detailing or rebar. And that's it. So bring in that bridge and you can immediately start with your rebar. Let's look at how it looks in Civil 3D. So I'm going to switch to Civil 3D very quickly. I am going to go and select that IMX file. So make sure it's toggled for IMX and not SQLite. Hit open. You'll see if I go to refine selection set, the only thing that comes through is the bridge because that's what was exported. That's perfect for me. I'm hit OK. You can see it's 96 entities. I didn't do a very small design for you guys, so it's something comprehensive. And once the import is finished, let's go have a look at how it looks in Civil 3D. All right, my cursor will be flashing a little bit because the parametric objects as well as the block definition that's going to be created now is just processing. Once that's done, let's go and zoom in here. And now you can see that the bridge has been in our model. Now this is amazing, especially if you're doing plan and profile drawings, because you will be able to see the bridge in your plan and profile, which is really cool, really cool. Normally we used to put like a rectangle there just to denote that bridge is at this position, right? Now you can have the actual thing in your log section. I could have done a crossing window here. I'm not sure why I use Select Similar, but anyway, AutoCAD comes into play again. So we literally did cover AutoCAD already. So I'm just going to select Similar, go to your object viewer so you can have a look at what it looks like in Civil 3D. Again, it's not as the level of presentation because we don't really need that in Civil 3D. You can do it in Revit and in Infraworks, but this is what comes in. And now it's part of your geometric design, placement, and modeling. And of course, if that IMX file is updated, I can go and refresh or update references, and that bridge will update not only in Civil 3D, not only in Infraworks, but also in Revit. You've got a nice triangle going along there. So anything updated in Infraworks, update the IMX file, save it, publish it, and then it will automatically sync once you hit update to Civil 3D and Revit. Damn, that was a lot of talking, but I think we're done, right? So let's wrap up and see what we had covered today. So of course, we looked at Infraworks, how you can bring in your civil design for your roads, platforms, gradings, those type of things into Civil 3D and do it a detailed design, be it in Civil 3D or Revit. We then also showed you or showcased the shared reference point feature that's built into Civil 3D under the subscription heading in the toolbox tab, that you can export a set coordinate and you can actually coordinate your Revit model to match the orientation that it should be on site. Then we modeled a conceptual bridge design where we did it very visually in Infraworks. You saw all of the functionality. It's crazy that it's a conceptual design tool with so much of detail. And then I showed you my novice attempt at Inventor, where I modeled that pier and pier cap, again using AutoCAD commands, which are very, very handy. And we then exported that to Infraworks, added it to our library, updated the bridge to match it. And then, of course, we exported an IMX file, we published a civil structure, and we imported that into Revit and Civil 3D, where we could do the rebar in Revit and also the sheets, as well as in Civil 3D for placement along the plan and profile drawings and long sections. Okay, so before we get to Q&A now, I see there are already a few questions, which I'm happy to attend to. This is how you can reach us on Baker Baynes. We're very active on all of our social media platforms, be it LinkedIn, Facebook, Twitter, Instagram, and YouTube. So please hit us up and have a look. Just Google or type in Baker Baynes. Subscribe, follow us. You will always be up to date as to when the latest webinars are out, not only in my industry, but even in architecture, manufacturing, energy, those type of things. And of course, if you want to connect with me directly, or you want to have a chat or a quick brainstorm session, whatever you want to do, you can connect with me. My name is Shoaib Yunus. I'm the BIM technical specialist, of course, for civil infrastructure and mining here at Baker Baynes. You can reach me on LinkedIn. You can just search Shoaib Yunus, it'll pop up. Or you can reach me directly on my work email, shoaib@bakerbaynes.com. And if you have any really kind words that you would like to share, please do. It keeps us on track and motivated to see that we're delivering the right content. Of course, also if you have constructive criticism, maybe some suggestions, feel free to pop it in. I'm a very, very chill person, and I really do appreciate the feedback that I receive. If you want to chat about anything, or what you can reach me on is anything civil infrastructure design related. If we're talking products, Autodesk products I use quite a bit is Civil 3D, Infraworks, Recap, vehicle tracking, AutoCAD, of course, laser scanning, BIM 360, docs, build, those type of things. Also design for Civil 3D, BIM 360 design. So if you want to reach out with me if you have a question, please feel free to. Getting tongue-tied on this Friday. And then, of course, secondary focus is more of the vertical construction stuff. So it's not my actual core specialty, but due to collaboration and stuff, I've picked up quite a bit on it. So advanced steel, Revit structures, robots, which we might throw into the mix soon, and of course, Navisworks. And I maybe could add Inventor there because I'm a bit of a novice there for civil infrastructure, right? Other focuses, I'm very big on the laser scanning part of things, point cloud extraction. So like I said, I use the BLK360 quite a bit, the GLS 2000 for TopCon, as well as Clear Edge Edgewise for automated point cloud extraction for elements. And if you're interested on that, I've got an Autodesk University session coming up soon in November. Please log on, it's free. You can have a look at our Scan to BIM topic, but I'll drop more info on that as we get closer to the time. And last but not least, everything that we share on our webinars and stuff like that are all uploaded to our Baker Baynes YouTube channel. So if for some reason you feel that you're not going to be able to make the webinar, still register for it so that once the recording has been published, you will be notified that it is available for viewing. Also, a great thing I've seen, not only in this webinar series, but the previous one, is fellow professional colleagues, draftspersons, tagging other friends and professionals in the comments when I post something. This is really good, guys, because we all want to learn together and upskill together. So please keep that up. Tag whoever you need to, who you might feel that they can benefit from this, as well as resharing our posts, resharing my posts for the webinars. The more people we get, the greater it is, the more we can digitize civil infrastructure, and the more we can grow as professionals. All right, so Q&A time. Let me go and just switch to the chat box so I can have a look at what comes up here. Okay, so I've got a question here from Najib. Najib, good to see you after some time there from Morocco. The question is, after importing the bridge into Revit, can we use the rebar function? That is correct. So remember, the geometry comes in from Infraworks as an IMX file. That geometry cannot be edited in Revit. It is the final product, if I could call it that. But you can do your rebar from there. So all of your reinforcing and stuff like that can be done. And yes, you can use different rebar parameters per component. So you would know your detailing depending on what you're doing, whether it's a pre-stress, post-tension, pre-tension, what type of rebar reinforcement you're using, those type of things. All of that can be done in Revit. If you want more control of the geometry in Revit itself, then I would say this workflow, you would need to do it with Revit, Civil 3D, and Dynamo. So how that works is you can import or link the road as a CAD file, or you can bring in the alignment as a reference for your bridge, and then you can detail from that reference position going down. Okay, it's much more of a not as straightforward as what you've seen here today, but it does work pretty damn good. Good question. Thank you for that. If you have any questions, please feel free to fire. It doesn't have to be a question. It could also be a comment. So if you like what you saw here, feel free to share. I'm just browsing through the rest of the questions so long. So I'll give it a few seconds, a minute or so, maybe if you have any questions from there. Okay. So this is a good one. I'm glad someone actually noticed this, right? So they do not see the shared reference point option in Civil 3D and in Revit 2021. This is true. Okay. So as you know, Autodesk normally like releases their latest versions like half a year advance in time. So this is just to give you a preview in terms of what you can do and stuff like that. I would call it in test stage. So this install file has not been made available yet for 2021 versions, but you can use the 2020. So I would strongly recommend keep your 2020 version of Revit and Civil 3D on your PC. You can use the shared reference point there, create it, and then you can always upgrade the file to 2021 and keep working. I am also keeping my eye out for when the shared reference point add-in will come in. It should be in a matter of time now, but I have checked the forums as well. It should be out pretty damn soon. So good question, good eye there, and thank you for that. Let me make this a bit bigger. The window for my questions, it's a bit small. Sorry, guys. Carl saying it was a great webinar. Thank you, Carl. I really appreciate the feedback. Structural engineers saying the same thing. Look, guys, it is, like I said, you'll have to use Inventor for this workflow. I am a novice at Inventor, pretty elementary level, but I was able to model this. So if you've got a good grasp of AutoCAD, you can definitely bring that into your arsenal. So really good. I'm glad to see the structural engineers happy. It's normally quite a bit of a mission being in the civil structural space myself. So that's always great. And there's another one here. Looking forward to part 3. What will it be covering? Ooh, putting me on the spot here. I haven't really decided that yet, to be quite honest. I still have to finish off the final civil design that you've seen here today. So I'm going to be a little bit busy with that. But keep your eyes peeled. I will definitely share that soon on LinkedIn, so you have an idea and we can take it from there. If you have any recommendation, by all means, you can always throw that out to me here on here. And yeah. Orias from Mozambique. It's great to see a lot of the people all, like over and over on the webinars. Great webinar, need more info on Inventor, especially for Revit collaboration. Probably drop me a message on LinkedIn or hit me with an email. I can send you that. But all of that is detailed in the Infraworks help file. Okay, so if you just type in Infraworks help file or you go to the help option in Infraworks, you will find more than enough information, probably explained way better than I have done here today. But I'm glad that it made sense and you like what you see. Okay. Okay, there's another one regarding formats. So format is more of an architectural sketching tool, right? If you don't know what it is, but it's a really good place to start. If you have a format design, you can actually assign textures to it, do your model, send it into Revit, and do a much more detailed design from that. Architects on here, you can always correct me if I'm wrong, or any renderers. By all means, if I'm wrong, let me know. But that's what you do with it. The question is, can you link it to Infraworks? Yes, you can. Very easily done. I'll actually make a note here. We'll see how much time we have. I could throw it into the mix somewhere, but good one. Any other civil questions? Let me just toggle through here. Okay, that's it. I don't see any other questions. I will just put my details up onto the screen one more time if you want to get in touch with me. Let's see. One more toggle through. Last time I missed a question here. I felt so bad. Yeah, I've answered all of the questions. So let me just toggle back to the slide again. Please reach out if you have any questions, any comments, if you want to collab on something as well. Hit me up. We can have a chat, talk about it. I hope this made a lot of sense. And I think I've kept you for quite a bit now, but I am going to say goodbye. So thank you everyone for joining me for this webinar. I hope it was insightful. I hope it made sense. I explained it as clear as I could as a designer. Have a great Friday. Have a great weekend. Yeah, catch you all for the next one. Stay safe. Catch you guys soon.